can just watch them for now. Not too worried about it. We can. That's fine details. We can watch them on my computer and respond.
What but if we're not going to get chat coming in, I don't need to have a space for chat.
Correct. Yeah, fair enough.
Yeah.
So don't bother.
Are we streaming to something right now?
Those things. Yeah, take a look.
Should be on Twitch and.
Oh, they can hear us right now. No.
Positive 12 volts, negative 12 volts, and 0 volts.
Our audio isn't working.
I guess we're gonna try again.
All right. Sorry, our audio isn't working. Just a quick recap. Hi, Glavin Lucas here. We're doing live stream engineering. Having a lot of technical difficulties today. We have our Raspberry Pi, and we're going to be programming it with Python.
Back to you, here's our new Raspberry Pi 3. What the benefit? Basically, it has a little bit more. Basically, the Raspberry Pi gives us the opportunity to use Wi-Fi connections for our for our control of our RC car or our autonomous car. But a recap of what we accomplished last stream is basically we built this circuit, which is the power distribution circuit for our car. So we have our positive terminal block, our negative terminal block. This will connect to the lithium-ion battery. The positive and negatives come to all three of these devices to supply the power. This device is the buck converter. Basically, it goes from 12 volts to 5 volts to allow us to power the Raspberry Pi in the future. This device is the motor driver, and what the motor driver does is basically gives us the opportunity to drive the motor and protect our power system from backfeeding over voltages, but it also gives us the opportunity to control the motor. So through digital modifications, we can basically change this from positive 12 volts to negative 12 volts to 0 volts, which would represent forward, reverse, and no driving whatsoever. You can also change the voltage output, and that would actually modify the speed of the motors as well. So our objective today is to simulate the connections from the Raspberry Pi to the motor drivers, such that the motor drivers will produce those positive 12, negative 12, and 0 volts to show that we have the opportunity to control the motors directionally when we get the car. Hopefully the car comes in this week and we'll be able to actually put everything together. So let's get rolling. That's sort of our high-level recap of what we've accomplished so far.
Awesome. So if any of you watched the last session, we were trying to get the camera on the Raspberry Pi connected, and as you can see here, Raspberry Pi with the, what is this cable type called?
It's a ribbon cable.
Ribbon cable connects to our camera here, And again, we're having some software difficulties, but we did actually figure out what the problem was shortly after we ended the last stream. So we'll continue on with that before we jump into using the GPIO. So let's just take a look here. So we have Belina once again connected. This time it's to a Raspberry Pi 3. Last time it was to the 2, but same idea. Then we're going to go and open up our device. So it's already hosting a web application. No, this one we didn't write. This is Belina Cam. It's a demo. Now we realized this main page doesn't work, and I looked through the code and it looks like there's a problem with how it's a little bit over-engineered. But if you type in this exactly, and we'll maybe send this link out, we do get a live stream. So I can actually show Lucas here, and I can show you that this camera is in fact pointing at Lucas. So I can see that this camera, so you can see it moving. So the problem was the website and all the JavaScript and whatnot. It was trying to do some pretty complex stuff to initiate that connection, and that wasn't working. But it was actually sending video feed, but the after it got the video feed, it wasn't working. So we'll get into that probably in a later chat, but we just wanted to make sure the camera did work. It wasn't our objective to dive into all the cool camera stuff we will be doing later, but at least just to make sure the hardware we purchased is working. So at least we're back on track and finished the last stream. So now let's dive into using the GPIO connectors. So we're going to close up this here. The nice thing about Belina Cloud is it already comes with an easy way to select the terminal. So you can go select, in this case, our application is Belina Cam. That's the application name. And we can start connecting to this terminal. And terminal, in this case, is a way for us to remotely connect to one of our devices over one of the protocols called SSH. It's just a secure way of communicating. So it's going to boot up right now. And this is, again, in a web browser, so it's nice and easy to work with. We probably won't dive too much into terminal specifically this round, because we want to really focus on the Python, and we want to focus on the parts and the GPIO, so we can actually connect to the motor controller and test that all of that is working. But I'm sure later on we could definitely dive into other terminal things. If anyone's else interested, leave a comment. Okay.
Yeah, in my opinion, we're going to get into some maybe a little bit more complicated topics. And I would imagine that there's going to be a lot of questions. And we sort of skipped over how to actually get Belina up and running. So if you have any questions or want any further information, we can definitely go in depth on that in another stream or even later on in this stream with plenty of time. Belina, Glavin introduced me to Belina, and I flashed the new Raspberry Pi today with Belina, and it was very efficient. It happened very quickly. I was pretty impressed with the piece of software, especially for a free piece of accessible software.
Having a little bit of technical issues here. Trying to SSH into it. Okay, here we go.
All part of the process.
All part of the process. So our goal is to actually follow a similar tutorial like shown here on the right-hand side, which is connecting to our general purpose input-output pins. And then we can configure them to say, hey, these are output pins, or in some cases it could be input, but we're just going to be focusing on output for this particular event. And then we can do different actions. In this case, these guys have a switch and they have an LED, and they're configuring those pins as such. And then we're looping over them and doing different things like turning them on and then waiting and then turning them off and things like this. So we can just test to make sure all of this works and use our handy multimeter to verify everything. Okay, so we're using Python 3.
You never heard of Belina, Lorianne? Yeah, it's worth getting introduced to. It seems like a pretty useful piece of software for any sort of embedded type projects with Raspberry Pis, Arduinos, or I'm sure that it's also compatible with other microcontrollers as long as they have internet capabilities.
Yeah, and the nice thing about it is it's really great if you have a lot of these devices. So now we have Raspberry Pi 2, Raspberry Pi 3. Maybe we get more devices down the road. So you end up having quite a few. And when we were setting this up, we could simply say, I have the Balena CAN application. It's already installed and built for my Raspberry Pi 2. So I was able to just go in there. Well, actually, I can even just show you very briefly.
In the past, I had a lot of...
Go in there and you could just say, hey, this device, I want to go on this application, and switch it over.
In the past, I had a really tough struggle with Raspberry Pi because you can't actually SSH into the Raspberry Pi until you've set it up, which means if you don't have a way to flash the Raspberry Pi prior to setting it up, you don't really have a way to access it without a keyboard and a mouse. Didn't have a keyboard or a mouse or a way to flash the Raspberry Pi prior to using it, so that was a tough workaround. That was the first time I ended up flashing the SD card outside of the Raspberry Pi. That was the workaround in that situation. Because as you can imagine, when the computer says type no keyboard found, it'll say no keyboard found. Press any key to continue. It's a really big struggle pressing a button when there's no button to press.
Yeah, that's for sure. And what's nice about Balena Cloud as well is they use another technology called Docker, which we won't talk about here, but the general idea is it allows other computers to build software in a really reliable and repeatable way. So when you're building for Raspberry Pi, it's not as fast as your home computers often. Like, they're getting pretty powerful, but let's say you want to install some really interesting software. Often you'll put it on this device and then wait hours for it to compile from source and build it up. But with Balena, you say, hey, you guys, Balena, you build it, give me the final image, and then we just take that image and put it directly on the device. So all the processing, the really expensive, time-consuming part, is actually done in the cloud by really big servers that are handled and designed for this. And then the Raspberry Pi is simply saying, give me that final file, the last step, and I'll just run it as is. So that also saves a lot of time for deploying and just distributing things, and it makes it really manageable when you're dealing with more complex applications. So yeah, but again, more advanced features are really cool. All right, so we're having some issues here already. Our Raspberry Pi currently does not have the software installed for Gpio. So we're searching up Raspberry Pi, Gpio, looking for the library. PyPI, PyPI, is the package repository for Python. So this is the library kind of website that talks about this particular package. So we can go here, copy to clipboard, and then let's see here, exit out. So let's try to exit out of here. Looks like it froze. So our objective now is to install the library that we need. So this is a Gpio library in Python 3 specifically. Okay, it's still connecting. So we can take a quick look down here. Let's see now. Home page. They might tell us a little bit more about this application. Or not. So it's often really good if you can go find their website, because there'll be documentation on how to use things. Now, not every website is going to be nice and clean and easy to use. So here we go. To get started, it's worthwhile reading their examples. I should refresh this. I don't know why the VPN isn't working today. It's unfortunate. Let's see. Start reading. So, basic example. So we're trying to do something like this, where we can import from the library, Raspberry Pi, Gpio, that's the Gpio library, and then down here we can set the mode. Sorry, I have a little cough today. So you can set it up. You see this particular pin is either an input or an output. So in our case, we're trying to output values that would then connect to our motor drivers. In other cases, you might have a switch, and that's where the input would be more applicable. Alright, so I'm going to try to install here. There we go.
Yeah, so a little recap of what we're trying to accomplish today, just high level. We went over it at the start, but we might as well give you a little rundown again. Basically, what we're trying to accomplish is to use the GPIO pins on the Raspberry Pi to modify the output voltages on the motor drivers. So these GPIO pins, these pins, we're going to connect them with female to male adapters to the motor driver control circuits. And basically, we'll have an output at these motor driver outputs of either 12 volts, negative 12 volts, or 0 volts, or some variation of voltage that modifies the actual energy output of the motor. So basically, overarching, our objective is to digitally control the output of this device so that we can modify the direction and speed of the motors. We don't have the motors yet, but hopefully we'll have them within the next week, and we'll have everything already designed such that we can just plug it in and see it driving within minutes. I say within minutes. We all know that within minutes actually means within hours.
Yeah. Yeah, that's for sure.
Get the screen back.
Okay, so it has now installed using pip. So pip is the Python package manager, and we've installed our GPIO library that we want to use. So it's installed everything. It's good to go. I've now run Python 3 in the shell, in this terminal shell, and that's executing Python 3 in what's called a REPL. So what that means is rather than having to recompile your code, for anyone familiar with other languages, a REPL allows you to make line-by-line changes in real time. So you could say, yeah, use pip all the time, exactly, Lawrence. It's really, really helpful for Python. So REPL in Python means that we can run it command line by line. So let's say we want to change certain values. We don't have to wait and recompile our entire code. We're able to just make that new line, hit enter, and then it's going to reevaluate and rerun that code. That's one of the advantages of Python, is it's an interpreted language, not a compiled language. So we don't have that overhead of this compile time. We're able to iterate and develop really quickly and try different things. And that's going to make us really productive, especially today while we're prototyping it and learning new things. Lucas, do you have any questions? I wanted to mention something.
I don't have any questions. I did want to highlight, this is on another topic, I did want to highlight that we're using a pretty cool piece of software right now. So if you're watching us on our YouTube channel, you could actually check out our Twitch at twitch.tv/dvp_kamikaze and see that we're streaming the exact same thing on over both platforms. And you can actually see that the comments on the side of our chat box there, our comments actually filter in from both of those streaming platforms into one location. It's pretty nifty software that we're dealing with. It's called Restream.io. It seems very effective.
There's just a little bit of Restream there. Oh, it's not the homepage, but I'll show you what Restream looks like. So
Yeah, they're
go take a look there.
on the bus. And...
Oh, sorry. I was going to pull up the Twitch page as well. So what was your login, Lucas?
dvp_kamikaze.
So we go to Twitch, DPP.
KZE.
Boom. That's spell it.
I think so.
So that's what we're looking at using something else. It's a little bit harder to find people.
Oh, you're logged in.
How did that happen? Okay. Anyways.
I must have logged in to set up the restream.
Okay. Sorry. So anyways, just look up this username here. I don't know how to get to it, but I'm logged in as you. You should see something like this page. So, DVP, Kamikaze, and you'll see it in the live stream. So you can go on either of these sources. Definitely take a look, depending on what you're interested in, YouTube or Twitch. Okay, so let's get back to Python. So we've now successfully imported our library. And we want to first set the appropriate pin. So the thing is, we have to determine what pin we want to set. So maybe over to you, Lucas, to figure out which would be appropriate.
Yeah, so it doesn't matter too much. Would you Google RPi3 pinout?
Yep.
And we'll take a look. Take a look, and you can grab that first picture. It's fine. Let's blow that. Okay, so basically we're just doing a digital operation, so it doesn't matter if our GPIO is capable of using using some sort of communication protocol or PWM. PWM meaning pulse width modulation. It basically gives you the opportunity to fluctuate. Like if you wanted to simulate 3 volts, the way to get 3 volts is to turn 5 volts on 30% or 60% of the time. So pulse width modulation basically allows you to simulate lower voltages or higher voltages by fluctuating over time. So nonetheless, we don't need those functions, so we're going to use some GPIOs that are as simple as they can be turned on and turned off. Something like, actually, we're controlling motors. I lied. Let's use PWM pins. So GPIO 12, PWM 0. So on the right, so it's pin 32, but it's GPIO 12 in software.
So it's here GPIO 12, and you see 13 with it?
Yeah, let's do 12 and 13. Sounds good.
Yeah, so 32 and 33, depending on what the code wants us to provide. So it says channel, and what would channel represent in this case? Would this be the 32 and 33 value?
Set up more than one channel. You need a channel. You need to set up a channel every time you're using it as an input or output. To configure a channel as an input, GPIO setup channel, GPIO in. Channel. Yeah, I agree. To read the value. I agree. Channel is the GPIO pin number. How do you...
So 32 and 33, or 12 and 13?
It's a good question.
We can try them.
Yeah. Only one way to find out.
Only one way to find out. Okay, so when in doubt, let's test it out.
Let's test it out. It's going to be our new catchphrase.
Oh gosh.
So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
All right, this is a little bit slow. I might look up an alternative way to communicate with this. So, nice thing about Balena is it also provides you quite a lot of details about the device itself. So let's go. We'll minimize this. So it's telling me the local IP address. So here, Lucas's place. If you happen to be within distance of Lucas's IP or Lucas's home Wi-Fi, you could take a look at this as well. And we'll connect. Let's hope this works. So this is following the documentation for Balena for SSH access. Looks like it's not working. Because it's a little bit too slow for their website.
Machine.
Okay, well, we'll keep going forward. We don't want to slow things down, but it's going to be a little bit slow, so bear with us. Back to Python 3. So what we're going to do is try to connect to the pins similar to this. So we set mode. I think it's probably board. Let's see what that does. Specify what we're using, board or BCM. Do you know what BCM? Second number system of BCM numbers. Lower level way of working it refers to the channels.
I think we.
You want board?
Yeah, board.
So
I think that's the difference between. So this is where we set up. We say, is it 32 or 12?
So we actually tell it.
Yeah.
So if you look at this diagram, let's say we selected board, then we're able to say 12 and 13.
Yeah.
But if we selected BCM, we'd have to say 32 and 33.
I think it might be the opposite, but
Well, they said the BCM could break between different versions. So I suspect. Sorry.
oh, I see what you mean. So yeah, 32. I agree.
Yeah. So, but we'll try that out too.
I can hear you coughing
Oh God.
on the stream.
I don't know why it's so slow today. What's going on here?
Last time we worked on this, we had a direct connection to the Raspberry Pi, so it could possibly be slow because we have a wireless connection to the Pi this time instead of a hard connected Ethernet to the wireless.
Yeah, that's true.
And the Raspberry Pi's getting hot. Put on my MacBook as a heatsink.
Yeah.
Because we all know my MacBook can handle extra heat. It turns off, but it can handle the heat.
Okay, we're almost there. So what we're expecting is GPIO set mode board, and then the channel, in our case, since we're selecting board, I'm hoping it's going to be 12 and 13, and we want it to be set to out.
Multimeter ready.
Okay. Copy and paste time. Boom.
Oh, it works.
So, setting it to board. And then in our case, we want to go GPIO, setup channel. Our channel, let's do the, so you want PWM 0 and 1, so 12 and 13.
Yeah, so 32, 33. Are you doing board?
Yeah.
You're doing board, so it'd be 32, 33, right? So we concluded.
That was the opposite of that.
But you, like you said, it could break down.
BCM breaks down.
Yeah, so board would be.
I would have thought that the GPIO number would be the one that's consistent between versions.
All right, give it a shot. And worst case we're wrong and we switch back. But
Let's try it. So our current hypothesis is that board means GPIO 12, whereas BCM means 32. so that it could be either of these numbers. So we're going to try with 12, give it the board configuration. So 12, GPIO, out. All right, let's pray a little bit. Can I just do one of them?
Yep.
One of the pins?
Yep.
Okay. So,
theoretically. Oh no.
we have to do output heat. So we go output, output. Once again, we're going to do 12. And state, we'll do high. So what, like we said last time, high is voltage, low is essentially no voltage, and they get 0. High, I think, is 5 volts for us because we're working with the Raspberry Pi.
That's right.
So we would expect them to see on the multimeter 5 volts. So let's turn it on, and let's go take a look at our external camera with a Pi.
Okay. So I'm gonna try and find a way to. I'll be right back. I'm gonna get a piece of foam to prop that up.
I can hold it for now. There, perfect. Look at that. That's real engineering right there.
Okay, so you can see my numbering.
Yep.
So we're looking at pin. You said pin 12, and pin 12 corresponds to pin 32, which looks like it would be pin 32. So 1, 2, 3, 4, 5. So right there. So let's go touch that, and we'll also touch. We also have to touch ground to have a reference.
So ground is right next to it. That one too.
What did we get?
I see 0.
0, eh?
And it is set to DC.
What's that say?
So 0.
Okay, so let's try. Let's just test, make sure the multimeter is running. So this one should be 5 volts to here. You see 5 volts?
Yes, we see 5.
Okay, and the other option was we said 12. So 12 could be GPIO 18, which is 2, 4, 6, 8, 10, 12. Ground. You see 5 there.
It's moving. Give it a second. No, it's still millivolts.
Okay. Interesting. We have an issue.
Okay, maybe this code isn't working now.
40, 38, 36, 30. 40, 38, 36, 32. 40, 38, 36. Maybe it's this one.
Nope. Nope, still off. Okay, but maybe the code is doing something wrong. That you tested both.
Interesting. I'm in an interesting situation now.
So, take for example this LED board. So look at the numbering scheme here. They're selecting board.
Yep.
Using LED 18 and 31.
The only way to see 31
would be if it's the other way.
Would be if it's, yeah, this would be 31, GPIO 6. So we have 32, right? What did you program it to?
I'll put it to 12.
You put it to 12. So 12 should be this one. 2, 4, 6, 8, 10, 12. No, that's nothing. Neat. Import time. This is going to be an interesting adventure down the lane of troubleshooting. You can take your camera back. I'll be back.
So I think we did most of it right. We did check both both of those pins. So we're looking at this pin out, and if we look at this code here, they're using Gpio set mode board while also having that particular pin for LED be 18 and the switch be 31. Since you don't have a GPIO number that is 31, we can deduce from this that it must be board as actually representing the inside number here. So when we put in 12 for setup, so we had set up 12 GPIO out, it actually was referring to this 12 here, which is GPIO 18, and that's what Lucas was testing. So, so neither seem to work, so there must be something in our code. So we have to keep investigating. So unfortunately, it disconnected from the Wi-Fi again. Let's see. It says the device is not connected to the VPN. Well, it's restarting. I'm going to take another quick look at terminal for SSH. This is going really slow. Okay, so here's another option. So we should be able to connect to it directly using this SSH, given this port, root, and we have a development. You selected development image, right?
I don't think I did.
You selected production image?
I think it's like production image. Does that make a difference?
Yes, a lot. So we're gonna have we're gonna have problems. So like in this case, we're not able to SSH into it.
Okay. Well, we can reflash it right now.
Okay. Let's show people how to flash things.
Cool. We'll flash it. We're going to be flashing it from my computer, which is unfortunate because you won't be able to see my screen, but we can show you my camera at least. We can show you with the camera at least. Let's bring up Belina. So let's unplug the Raspberry Pi. Let's grab the SD card. We actually need one of these adapters for the SD card so that it can fit inside my computer. And we go into Belina. So we go into Belina, we click Add Device, Raspberry Pi 3. Raspberry Pi 3, Belina operating system. I clicked production when I should have went into development. Wi-Fi and Ethernet, and we'll need to put in my Wi-Fi information. I'll just I'm just gonna take. Bear with us.
Real engineering is messy.
Never works the first try.
Does anyone have any questions while we're here? So now we've entered that information. It defines a download.
Should be fairly quick.
And that download is an image that is, like I said before, when we're building with Belina, it provides a really fast, nice image that's everything you need. Operating system built, all the stuff you need installed. In this case, configured for Wi-Fi with the Wi-Fi credentials already provided. Using the conventional way of doing it, you may have had to flash the ST But then, let's play with Raspbian OS, I think that's what it's called. Raspbian. And then you go in, probably connect it with HDMI, probably connect it with Ethernet, and or actually you can just put a keyboard and then a mouse, and you have to navigate around and configure it that way. So this is really nice because all we have to do is flash an SD card, and then as soon as it's connected and powered on, it's going to connect to Wi-Fi or Ethernet, depending on how it's configured, and be good to go and show up in your Belina dashboard.
So yeah, while it's flashing that card, let's maybe talk about the car and how we see this working out. So we're planning to initially work with a piece of open source software called OpenCV, which stands for Open Computer Vision. So that's why we have that Raspberry Pi camera on our Raspberry Pi. It gives us the opportunity to use this Python library to try and use some machine learning to detect some items in the room and understand whether or not those items are safe or dangerous, and attempt to avoid them so that the car can drive freely and autonomously through the room based on some constraints that we set in our software. We're pretty excited about getting the car. We're going to be using those Mobius Mecanum wheels that have the opportunity to drive forward and reverse like any typical car, but it also has the opportunity to use translation methods to horizontally drive or vertically drive in ways that typical vehicles don't drive. One of these days we'll get a guest host or a guest star, and we'll explain from a vector perspective how the wheels actually work themselves. It's pretty exciting, and we're looking forward to it. Looks like the etcher is complete, so
Whoops.
the etcher is complete, so I'm going to take the USB, plop it back into the Raspberry Pi, and hopefully the Raspberry Pi will be noticed on our Belina application.
Oh. Oh, one more.
Several technical difficulties today.
Yeah. All right, so now we should be able to go into Belina and see it. One problem might be is I was configured for you, so I'm not sure if it will show up for me. Let's just take a look. So we can go into here. You've already added a device.
So we're still waiting for it to actually upload. Hopefully we'll see it soon. Or not upload, but finish booting up. It is a full computer, so it does take some time to actually finish booting up. It's not... yeah, I guess it is. I guess technically it would be booting up from solid state, but it's still just a $40 computer.
Yeah. Impressive, though. Maybe we could take a look at your screen as well, just to see if it shows up in devices.
Let's see.
So we have a few organizations under here. So we're under the behind the scenes engineering, and we should be able to see one of our new devices added soon. And adding a device is pretty simple, as you saw. So Belina makes that a breeze. Go. So once it boots up, you'll be able to plug into it. So again, what we're trying to do is, oh, that's the multimeter. So what we're trying to do, use Gpio, connect to those pins, and output.
So what was the issue with it being in production?
We're not able to SSH into it. And also, so the development image has other things that are, it's not as an efficient an image, but it has a lot of extra things, and one of which, of course, is passwordless, ability to access root, and SSH in.
You still can't see the device. It's really taking its time.
Yeah. Hopefully we did that properly.
This is unfortunate.
On all the technical difficulties today. Let's see, what else can we...
Yeah, the human difficulties, exactly.
Yeah.
So we're gonna try again.
So I don't even... when I go here, I hit device, it actually doesn't do anything. So I might not even have access to see devices since I'm not the owner of the account. So let's just take a look. I want to switch to the other camera. I'm gonna follow you. So under the organization.
Yeah, we're still trying to see if the device actually shows up.
Yeah, so it should show up automatically. And it looks like it's powered on all fine.
Struggling a little bit. Maybe we'll try again. I wonder if I put in the wrong password or something.
That could be it. If it's incorrect, it's just gonna not work. The other idea is we do have the Raspberry Pi 2.
We do have the Raspberry Pi 2.
Which is Ethernet. But it does make it difficult because we can't put it here.
Yeah, maybe we'll get you with the.
We can always
get you
boot them
started with
both
the
up.
Raspberry Pi 2,
Yeah.
just so that we can get through the actual connection process.
Yeah.
And while you're doing that, I'll hammer out this troubleshooting and get this guy back up and
through.
running.
Okay. That sounds good. Yeah, because we can run them both the same now.
Yeah. So I'll give you control. We'll plug it in over there. We don't really need it beside us right now.
Yep.
Take this one. For now.
Oop. This is a wild locust.
Wild
So-
Lucas. This is habitat.
So what we're doing right now is just setting up 2 Raspberry Pis. One is the new Raspberry Pi that we received, which is the Raspberry Pi 3. And it has Wi-Fi, but we're finding it a little bit slow right now. And having technical difficulties, it doesn't seem to be starting up. So we're going to try with the Raspberry Pi 2 and connect to it. So wish us luck.
Okay, so you should see the Pi 2 shortly.
Connecting. That's the Raspberry Pi 2.
It's Lucas again.
I do this.
Alright, so while he's working on the Raspberry Pi 2 and working on getting those outputs properly configured, I'm going to troubleshoot through the Raspberry Pi 3 and figure out why we didn't get access when I just flashed it. So I'll play around with that. We can do some simultaneous engineering. It's going to be great. I'm gonna let you guys watch Glavin, and just since mine's gonna be a bit more of bashing my head against my computer kind of stuff, which isn't as exciting, I would say.
I don't know. We'll do plenty of bashing our heads over here too. So I'm already seeing it starting to boot up. So let me take a look here.
Beautiful.
So I'm looking at the Belina Cam application. And again, Belina's really great because I already had the application installed for the Raspberry Pi 2, and we've got the 3. We could simply just say, hey, install it over there as well. So now that we've plugged in the 2, it is booting up, and you can see last seen. It used to actually say 4 days ago. Now it says online a few seconds ago, and it's starting to connect. And we actually have both connected, but you can see that the Raspberry Pi 3, even though it's been on most of this time, actually turned off now. But it was still going in and out of connection. Alright, so yeah, it looks like it's online. Everything looks smooth there. Let's see. Need a little more time. I think it needs a second because it's still booting up. The nice thing as well about Balena is we get logs. So if we have this application, in this case Balena Cam, and it's logging out information, it can tell us things about like the camera, for example. So the camera is not installed over in that guy, but that's okay.
It might run faster without the camera connected, and since we're not using it right now.
It might not run faster because it's rebooting itself. It expects the camera, so it's crashing the app.
Really?
Yeah.
Crashing the entire Raspberry Pi.
So I can show you what that code would be, but yeah, it looks like it is. So it's failing. It says video device is not found. It turns it off and restarts it.
Okay, we'll plug the camera in just to bypass that, so you don't have to over troubleshoot.
Yeah. Yeah, and I can show you guys where that actually comes from. So if we look at the Python code for Balena Cam, we can go in here on the website under app server. So this is the code that is being run every single time it starts up. And if we go down to the bottom, so here we're checking readiness. It's the first thing it does. So here it says if not device exists, so if the video device, video here, if that doesn't exist and the system is Linux, device is not ready, we print out we're trying to load, we go to sleep, and we exit. So this exit here actually just kills the whole application, and since Balena's image for Raspberry Pi, its whole purpose is just to run this application, you can see it here, service exited, restarting, and we keep getting that error message. So it's plugged in now?
Yep.
It seems to disagree. I might restart it.
This may end up not being the most productive stream we've ever had, but that's okay.
Yeah.
Some streams are headaches. Some engineering is headache. Application. Device. Development.
I'm sure the ribbon is still not seeing it for some reason.
No. Should have lost it. You should have done this.
Okay, I think it's just starting up now.
Technical difficulties on both sides of our stream. This is interesting. Let's make sure
No. That's interesting. Oh, here we go. All right. Okay, good. So you see before, it says device not ready, and it kept on restarting. See, service X is restarting service. But now, it went past that, it says device is ready. This is the line of code that I was hitting. And now it says it's running. So we should really go here. Now, like I said before, this application is actually a little bit broken. So it doesn't actually work, but if we go to the direct source, we do see a window in the video. And let me go jump in front of it. There, so you see me upside down. Okay, very good. We now have a Raspberry Pi that we can connect to. So let's see if we're able to connect to it over SSH. And it tells us our IP address. So local IP 192.168.0.31. We're going to copy this port here, which is what Belina is using. Copy the IP.
What the heck is going on? Look at this. Oh, it must be catching up because I wasn't looking.
Oh man.
That was interesting.
Oh, this is so much better. Oh my god, it's so fast. Oh. Oh.
It's the little things.
Okay. So. Next thing. So now we're connected inside here. But we don't have access to anything like our Python 3 for some reason. So 1 second. So what we want is to connect to the container. Oh, interesting. Okay, so that we're getting closer, but we're not entirely there. Because we're not, I think we're not inside the container. Because Belina itself runs host OS and the webcam application. Okay. trying to figure out how to connect to the Belina.
It's easier now.
So I think I'm connected to the host. So if I'm in here, I have access to Python 3, which is the actual application.
You could just pip install it if you want, and then ignore the fact that you're not.
No, I don't have pip. That's the point. Is it doesn't have a. Yeah. So I'm not inside.
You could ls around, see if you're just not in the folder.
It's actually Belina works with Docker containers, so it's how to actually connect into the container inside of it. It's like a separate piece. I think this might be what we need. Belina engine. Yes, there we go. So Belina engine, it sounds like that's what we need to be using. Thanks to this article here. So SSH access into running containers using standalone SSH. So standalone SSH, which is this command, we connect it to the device over root. The problem is it's using host, but not the application. So there's a script inside called Belina engine, and we should be able to jump inside and connect to it that way. So we need to first figure out how to list off what connections we have. So I think if we do exec, and it's Belina cam. Nope.
I just spelled Belina wrong, I think. It's B-A.
Oh, God, I am. Thank you. It's probably because it needs a container ID, not a container name. So we need to get the the listing of all containers. So list containers here, PS. So if you look here at the bottom, hopefully, I don't know if you can see this actually. So we run Belina engine PS, then we get names and containers and things like this. Actually make it small enough that I can see the full thing. So here is the image, here's the container. So if we do this again, but we're going to give it the container ID, not the name. And I think now we do a Python 3. Good.
Dang. That was pretty slick.
Back on track. All right.
Clever solution.
So now that we have this, now we have a really nice terminal. It's very fast. This is really smooth. Now, as we did before, we're going to find if we want to Python 3, and if we try to run that code that we previously had, this import command, we're fine. Again, no module named rpy is found. So what did we do last time? We went and found the PyPy page. So this is the package manager for Python. Copy this command. So pip is the package manager, install is the command for pip. This is the package name. It's rpy.gpio. Boom, good to go. Nice and smooth. Let's go and run Python 3 again. Go back here. Run this command again. Nice. We are back up and running. So, once again, we're going to configure this. This time, oh, I can't hear myself. Oh God. Let's go and create a variable in Python. This will be one of the output pins. A motor pin 1. Would it be better to have motor pin speed and motor pin direction? Is that you said you want to do?
Well, I think right now we're just testing. We'll have to write a script when we go down to that that level of detail. Right now we're just seeing if we can get it to turn on, I think.
Cool. Can we get it to turn on? Easier said than done so far.
Yeah. Definitely expected to be a little bit further ahead, but I suppose you got to expect the unexpected.
Yeah.
So,
so we actually want to get this pin here. So 32. And then we're going to set it up. Gpio Setup loader pin 1. It's going to be Gpio out mode, similar to this. And then we're going to run can actually set some output. GPIO, output, motor, bit 1, GPIO, high. So, let's go take a look at their camera, see what it says.
So you have motor pin on 32, and supposedly it's on high.
Supposedly.
Okay, let's give it a shot. So let's bring that camera over if you like. So the counts, I believe, for 1 second, I just need to check how the pins actually they count from 40 and we want 32, so 5 up on the right. Okay. 5 up on, so we start, so this one at the bottom right here is pin 40. So we want pin 32, so 40, 38, 36, 34, 32. Ground. Technically anywhere on this should be good. Anywhere that's not an electrical connection should be ground.
Probably had some in a second ago. It's fluctuated so much.
Very hard to test this. Oh, it'd probably work if it would work better on DC, wouldn't it? Oops. So that's 5 volts to test. Nothing. .2 volts on fan 40, 38, 36, 34, 30.
Something 30? Let's see what that means.
Pin 30 is ground. What? Why is ground showing?
Is this the right pi? I don't think it's the right pi.
That's Raspberry Pi 2.
I don't know. This is weird.
Okay. Oh, I think I was grabbing the wrong thing for ground. Actually, I think I just proved the opposite. Yeah, this is my fault. Sorry. I think we proved that we have 5 volts by accident. Or backwards. Backwards method. I was holding my pin on a 5 volt pin, or holding my multimeter on a 5 volt pin, which meant if I saw 5 volts, theoretically it would see that they were the same and show 0 volts. Interesting. Maybe we have some more learnings to do.
Alright, let's go take a look. So, our code right now doesn't do very much. If pin 19 is connected to LED film switch.
I'm gonna put an LED on pin so I don't have to keep testing with the multiple.
That's a good idea.
Yeah. I'm gonna do that.
So did it say PWM? Are these pins?
Yeah. Let's try. Yeah, let's
Is there
try
a different way to communicate with those?
possibly. So instead of going through that, let's maybe choose some different pins, just so we can get something working, so we at least understand what we're doing. So let's use pins, maybe 17 and 27 on the left there. So 11, yeah, those two. So 11 and 13.
Well, no.
Or just deal with 17. So pin 11. Are you sharing that screen?
I am. No. Engine. So we had to spell it correctly. It's with an A. There we go. Okay. Okay. Let's go my pin. So we want to try 17, so that's pin 11. Gpio setup. My pin. Actually, let's just set mode first. Alright, so we're going to set the output.
You're using pin, which pin number is it?
11.
1, 2, 3, 4, 7, 8, 8, 2, 1, 7, 9. So we should see this light up if you're using it. Nice, of course.
Oh, so one sec, guys. Let's just show you what that looks like.
Yeah, I'm going to take the camera and
Well, walk
run
over
through
there.
the explanation. So what we decided to do is, instead of using the multimeter, which is tough to use on those very small pins, decided to plug in an LED to the two pins that we're trying to control. So you can see here, that the LED is lighting up.
It's me.
Lighting up and turning off based on Glavin's control. So we proved that we can control the output of pin 11 over software, over network. So that'll be the basis of our control system for the motor driver controls. All we have to do is do that 4 times to control 8 times on 8 different pins to control all 4 motors. And have them go forward, reverse, etc., etc. So that's 1 pin down, 7 to go, and realistically at this point it's copy and paste.
Yo. Looking good.
I'm still struggling on my end with getting this Raspberry Pi to operate correctly, but that will come.
So you get see here, set to pin 11. Went from high, low, high, low, high, low. And that's why you saw it blinking. Your camera is sideways. Oh gosh. When was it sideways? I feel like that might have been a while ago. Is there something that we should redo? Not so kitty. So we want to have 4 of these. So actually, let's make it a little more polished. We will actually make up a script that I have Vim installed.
No, you don't have Vim installed.
You know what we have? We have Nano.
The best text editor there ever was.
You know what we're not going to use?
Oh, get out of here.
What is this? Do I have app yet? I do.
Lena, why can't you see my Raspberry Pi? It's a whole new issue.
So we're just going to update this a little bit so we can install Vim, which is the best way to edit over the terminal.
That is not correct. Is this headless? Or if I plugged it in, would I be able to see the...
I don't know. Let's try it.
Okay. I'm gonna feed this one from the other Raspberry Pi.
You're gonna plug in a Raspberry Pi into a Raspberry Pi.
Raspberry Piception.
Take a look. Here's Lucas just going crazy with Raspberry Pis.
I'm gonna plug in my Raspberry Pi into my Raspberry Pi into the TV. No, I'm gonna take over this screen. Can I take over this screen? Briefly?
Which screen? This one? No. Actually, no. Because that will mess up my feed for OBS.
Oh yeah, will too. Interesting.
Just plug it into a TV.
Yeah.
The TV probably has HDMI too. Well, it's probably not on power though.
I just don't remember the trick on HDMI. I will.
Take the one from your PlayStation.
Yeah, I'll fix it. Actually, this is the one from my PlayStation.
Oh, I see.
Already stolen.
All right, so we'll go back to me for a moment. Oh my God, you okay?
Yeah.
What's going on over here? Oh God. Do you want to pull up? 1 second, while we.
Oh, it's a very tight wire. Okay.
Good job for not pulling the monitor down. That would have been bad.
That would have been bad. That would have been very bad.
Gets a new monitor, immediately pulls it down.
Yeah.
A little bit. All right. So we're just checking here to see if we can install it. Yeah, now we're talking. It's installing. Get some
Nice.
Vim up in here, up in here,
I
up in
don't
here.
want that.
You're gonna love it.
I don't need that. I'm gonna write the TVs.
I love it. No nano. When Lucas was carrying the phone, it was vertical. I see. That's right. We'll try to keep it. Try to keep it the way we want. This work? Oh, it did. Okay, so Vim is VI improved. Actually, don't know what VI means, but probably just so it's just a text editor. It's really awesome, but there is a pretty steep learning curve. But once you learn it, then you're very fast. I definitely would do a Vim session later on with people if they're interested. But for now, I'm just gonna glance over it. Just picture, picture yourself trying to edit a file. Neither use Nano. So Nano here. It actually provides the commands below. How to exit. So this is like Control X, or I think there is a way to save. I think write out means save. In our case, we want to, so we have a couple files here. We want to edit, let's say we'll make a new file. We'll call this file, our motor code, motor Pi. So touch, what touch does is it just creates a file with this parameter name here. So in this case, it's going to be motor.py. So create new file. ls is listing all the files in the current directory, or a folder. Directory and folder are pretty much synonymous. So now see we have motor Pi. If we do nano motor Pi, we'll see it here, and we could code things. Let's make a comment. This is a Python comment. If I go Control O, it will say write to this file, and I'm going to say yes if I can figure out how to do it in Nano. I think maybe just here. There we go. Just enter. Control X is exit, and I'm out. But I prefer Vim, so you can feel free to choose whichever you would like. Boom, and you can see we've already edited this code. So that is great.
This, so I can type whatever I want. If I type in SC,
That's scary. People have taken over Luke's computer apparently. All right, so this thing up top, it's a shebang, and the long story short is that if you put this at the top of a file, it will allow you to execute it. I'm not going to get into too much detail. Again, I can answer questions on this for later, but we're saying this script, because it's a text file, is actually executable if you run it through Python 3. And Python 3 is located in user bin Python 3, and that's the executable. So we're just going to copy that as is. I'm not even sure if that will work, but I'll just double check. So how you determine what that should be is you go which, and you have the program. So in our case, we can go Python 3, and that definitely executes, so we know that's the right script. If you go which, it will actually give you the name and location of that script. So in this case, user bin Python 3 is correct, so our shebang is good. Now, if I do ls-l, this means long. And it's going to tell me a lot more information. It's pretty useful. Again, I won't get too much into this at this session, but one important piece, if I look at here, motor.py, it's read, given given the R, write, given the W, but it's not executable, and I actually want it to be an executable. So I'm going to do motor.py with the plus. So change mod is changing the actually I can do this. Man is manuals. Change mod. There's going to be a lot. Sorry, manuals is not installed. So chmod is just a nice way to change the access permissions of a file object. So I have a file, motor.py, and I want to change its permissions. I want to add, with the plus sign, the executable access. Excuse me. So if I ls-long, I now see it is executable. And that means I can go here and run it this way, motor.py. So with this /, essentially means, use the current directory, but I'm not giving it a command. I'm not saying Python something. I'm saying just run it as itself. It doesn't do anything right now. So I could do Python 3 motor.py. That would also work, but I just want to cut that down. So motor.py, and one moment. Lucas, do you want to take over for a minute?
Sure.
Maybe it. Yeah.
Switch back to the. Yeah, so Glavin's been distracted. I'm not gonna take over his software application. I just figure we can talk about what I'm trying to accomplish with my problem solving over here with the Raspberry Pi. We're basically at a point with the Raspberry Pi 3 where we can't see it on the network with the newly flashed SD card. The SD card should have basically an operating system running on it that accesses our network so that we can see it in the Belina software and manipulate it the same way that we're doing with the Raspberry Pi 2 on Glavin's shared screen. But we're struggling a little bit, and it'll be probably some offline troubleshooting at this point because it's, like I said before, beating your head against a computer until it works. So anyway, that's where we're at with that. But I think Glavin's back, so I'll give him back control.
Hi guys, I'm back. All right, my driver's coming to get me, so we have another 15 minutes, I'd say.
Okay.
All right, but we're making good progress. We finally got it working.
That's great.
So let's see now. We want to rewrite that code that we had previously. So, oh, you want to see more of me, do you? All right, back to code. Okay.
That is how you bring your damage.
Yeah. So we're going to paste in the import statement to get the library. We're going to paste the set mode to get board. We're going to set a pin. In this case, we'll just put motor 1 pin. Now, for every motor, we actually have 2 pins. Isn't that right, Lucas?
That's right.
We have speed and direction. Is that how that works?
No, not quite. So speed is going to be controlled with PWM. So that means that if we provide less voltage, it's going to actually provide less voltage to the motors. The reason we have 2 pins is so that we have multiple options. So if one is high and the other one is low, that would be forward direction. If one is low and the other one is high, that would be a reverse direction. And then if they're both low, that would mean off. So we need 3 conditions, and the only way to get 3 conditions is to have both pins having operation control. You need 2 pins to make up to 4 operations. Yeah, that's it.
All right. We'll start with 1, but we'll come back to it. Was that pin 11 over there?
Yeah.
Okay. So let's just get back to where we were before. We'll set it up. Go to pin, then we'll change this later. Gpio out. So I'll comment this. So when you write a comment, you just put the number sign in front of it. So import library. So we're going to import our Gpio library. Remember pins for later. Configure or configure pins. Drives 2 pins. So now, actually, so we got. Actually, this is the wrong one. This is configure board, like configure mode for everything, I suppose. And this is configure individual pins. Oops. Configure pins. Okay, and then we're going to go back and we will set the pin. So we'll go output. Motor 1 pin, in this case Gpio high. Great. So we will save this file and we will run this file. Well, I don't know what that means.
Channel is already in use because you didn't turn off your first, because your software outside of the script is still running, probably.
There's a cleanup that maybe I should ran that I didn't before.
So just a reminder, channel is referring to which pin you're using. So the channel already in use, my suggestion would be that the old script to use that channel as an output was still running, and then he tried to overwrite it, but it basically warned him that that's not okay. That's a guess, not an answer.
Yeah. Probably I don't have that old script anymore. It's gone. It's been executed and closed. Okay, so I was hoping I could clean it up at the top, but I guess it's not. So. And, okay. I did see something about warnings in these documentation here.
Once we get through this hurdle, I think that'll be a good point to call it for today. Get ready to pack up and start our Saturday night.
Yep.
Saturday.
So I'm just going to print something out. So Python, print to console. So we put a little article here. So we can print out nice text. and that's using this print function, using pin and motor one pin. That way when we execute this, we get a little bit. So I'm used to JavaScript, so this is why I forgot to cast it to a string. I wonder if I just have to put, yes, okay, so you see here, so this, if you just comma separate them, I think it should work. So I put a plus sign, this is a number, this motor one pin, and this is a piece of text, a string as they call it. So I was trying to add them together. And in JavaScript, this is okay, which is what I usually do. I'm not really familiar with Python, so this was kind of a translation error. Good, so that worked as expected. And actually, it should be showing the light right now.
No.
Okay. What if it's not showing the light because I cleaned up? So we got, and it's pin 11 over there?
Yeah.
So it's set to output, set to high, and then we clean up. So let's actually put, let's put a wait. So we want Python, how do we sleep? I want it to sleep for say 5 seconds, that we can go and take a look and say, hey, this actually needs to show us something in the light. So how we do this, there is a sleep function in the time module, and you can learn more about it over here. So time sleep, and you pass it the number of seconds that we want to sleep in this case. So, and you can pass, of course, decimal values as well if you want to make it sleep even quicker than 1 second. So in our case, let's make it sleep for 5 seconds.
Right.
5 seconds.
We gotta pay attention to Nacho Kitty. She's giving us advice.
Oh my God, Nacho Kitty, thank you. All right, so you can use cast to string. How do you cast? Oh, this str. Okay, and then using pin format. Okay, that is a good idea. That's what I get for using 2 screens. I miss all this great feedback. So let's actually try what Nacho Kitty is suggesting. So I will again comment this part out, and we'll try a different way.
She's also suggesting that we should increase the size of the phone.
Just finish up the stream. We're just finishing up the last 2 minutes of stream.
Increase the font size of this here.
One last little troubleshoot.
All right, so we have our code. We're going to format it using pin, and then what was the command that you used to format? Let's just look at Python. I see. So it looks like it's these braces here. So if I do these braces, format, I pass it motor one pin. Boom, that was great. Thank you, Nacho Kitty. That worked really well. Backseat coding is well appreciated because I'm new to Python, so we're learning this together. This is great. And let's see, I think the code exited already, so that's not going to help. So let's actually add a couple more pieces in here. Print. Everything. And then done. So now we can actually see what's going on. Waiting, and if I do see the light, we're going to need to be able to quickly switch between that. So let's actually increase this a little more.
So it's actually working?
It is totally working.
Sweet.
Yeah. Okay, I'm going to increase this to maybe 20 seconds.
Let's call it there. That's a win at the end.
Yep. So if I run this, so you see it's waiting now. I'm going to switch to our camera, and you can see over here, you see that little red light on the Pi, and in a few more seconds, it's going to wrap up, and it will turn off. And it does done. Boom. And you see the light turned off, and it cleaned itself up. So there it is, working.
Perfect. All right, so I think that's a good place to end the stream. Thanks for watching, and hopefully you'll come back next time. And next time we'll have the car and actually be able to make this one big moving operation. It'll be great.
Put it all together.
Yeah, that's right.
It's going to get really cool. Thanks,
All right.
everyone.
Thanks, guys.